Hello everyone, in our series of experiments on computer graphics, we have already discussed an experiment on clipping, line clipping and polygon clipping algorithms. So there were Cohen-Sutherland and Cohen-Sutherland-Hodgman algorithms being used there. Today I will be discussing another algorithm, liang-barsky line clipping algorithm. The, if you can recall what we have to do, we are given a boundary, a clipping boundary within which we have to decide which part of the line we have to accept, and if the line is completely outside our window boundary then we reject the line, and if it's completely inside then we accept the whole line itself. So in the Liang-Barsky algorithm we use a parametric form of the line, which can be represented here as x equal to x1 plus t into x2 minus x1 and y equals to y1 plus t times y2 minus y1. This parametric form of line, we can use this to get the endpoints of the line, and we can actually judge which part of the line we have to accept and which part we have not to. So we can just define the boundaries here. Xw max and Xw minimum min actually represents the boundaries of the rectangular window we are talking about. So we have to just make sure that our x coordinate, which is represented x1 plus t into x2 minus x1, this should be within the boundaries, and similarly y should be within the boundaries. So these are the expressions to represent that our coordinate should be within the boundaries. That will be the part of the lines we will be accepting. We can actually do some transformation here. We can define p and q variables for different edges of the window. Like p1 represents the left boundary, which is this one. So we can actually define p and q variables for the four different edges of the boundary. Here p1, for example, for the left boundary represents minus x2 minus x1, and q1 represents x1 minus xw minimum. Similarly, we can do the same for the different edges of the our required window. So what does this expression actually represent? T into pk is less than equals to qk. It represents the same inequalities we were having above, but in a simplified manner. So instead of multiplying x2 minus x1, we are multiplying t with pk, and the value of pk changes according to the edge we are talking about. And I've here defined what p represents for different boundaries of the window. Now we need to know what these values of p and q actually inference. So taking a case when the line is parallel to any of the window boundaries, if a line is going like that, it can be either passing through the boundary window or it can just pass outside the window, but it should be just parallel to any of the edges. In that case, the p value for that edge becomes 0. If the p value is less than 0, then the line can be considered going in an increasing manner, coming from outside to inside. That means it will be entering the window. And similarly, if the value of p is greater than 0, then the line goes from inside to outside. That can be called the case of the line exiting the window. Now taking other cases where the value of p is 0, that means the line is parallel to any of the edges, but the q value is less than 0. Then we can say that it is outside the window. So how can we judge that? For example, take any case like the value of q1 is x1 minus xw minimum. So if this value is less than 0, then it will actually mean that the x1 coordinate is which should be somewhere to the left of the left boundary. That is if the x1 coordinate is to the left of the left boundary, which will mean the x1 value will be less than the x minimum value, then it will mean that the line is starting from that point is somewhere outside the window boundary. So this is how we have to judge each and every time. According to the value of q, we can say that whether it is inside or outside. If we consider same case for the left boundary, the expression is x1 minus xw minimum. So if this value is positive, then it will mean that the x coordinate is within the clipping window, because the value is positive, it is greater than the xw minimum. So that's how we will be judging for all the edges. We will be judging the line whether it is parallel to any edge, or whether it is going inside through the edge, or it is just outside. Now we also have two different parameters here, T1 and T2. For any edge, the parameters T1 and T2, these are to be considered only when the line is not parallel to, is actually is not, it's not parallel, and it is going through the clipping window. What does T1 and T2 actually represent is, T1 represents the entering point and T2 represents the exiting point. So how will we get the values of T1 T2? If the pk value is less than 0, which actually takes the case when the line is going from outside to inside, then the values can be taken for T1 and T2 as qk divided by pk. This k, I have already told, is representing the edge. For any edge, if the value of p is less than 0, then its t1 value or t2 value can be considered as the maximum of 0 or qk divided by pk. So we actually mean to say that the value of qk has to be greater than 0 and less than 1. Similarly, if the p value is greater than 0, then we will take the value 1 or q by p, whichever is minimum. Now when we have got our T1 and T2 values, we can actually do some more judgments on the line. So if the T1 value is greater than T2, then the line is completely outside the clip window and it can be rejected. So these will be the cases where if T1 is giving you a point somewhere outside the window and T2 is also giving you a point outside the window, then we can actually say that the line is completely outside our window. Now talking over each and every step, how we will calculate the portion of the line which should be considered, we will just take a look at our algorithm. For initializing the value, we will take T minimum as 0 and T max as 1. This simply represents T1 and T2 for all the edges. Now for all the edges, we have to define T values. We have to find those T values. How will we get them? We will just divide, as mentioned above, we will judge according to the P value. And I've already told you how, if P is less than 0, then the value will be the maximum of 0 or Q by P. Otherwise, if P is greater than 0, then the value of T for that edge will be 1 or Q by P, whichever is minimum. So for all those edges, we will be calculating the T value, and then we will go through this algorithm to check, to decide which part of the line is inside the boundary. If the value of T for that edge is less than the T minimum, which is set as 0, which is initialized as 0, then we will just ignore that edge and move to the next edge. Otherwise, we can actually say that we actually have to say whether the T value is for entering or exiting value, which means we have to decide whether it is T1 or T2. If it is T1, it means it is entering, otherwise it's exiting the edge, exiting the window. If the value of T is entering value, then at the point of intersection we have to take the point of intersection as the starting point for the line. So in the case of entering value, we have to just set the T minimum value for T equals to T for that, like whatever value of T we are getting for that edge, we have to set it to the T minimum. Otherwise, we have to set the T max value for equals to that T value of that edge, which will actually give us a line. Accordingly, we will get a line. If the T minimum value is less than T max, which will obviously happening, so we will get a line from x1 plus T minimum x2 minus x1, and I've just defined these coordinates for the line according to the T minimum and T maximum value. In other cases, when T minimum is not less than T max, it will actually mean the line is crossing over the window. So which means it will just go through the window. We have to take intersection points in that case. So the values of T minimum and T max are already set, and when will we be using them for plotting the line, we will actually get the part of the line which is within the boundaries. So our job will be done. That's what we have to do. We have to take only the part which should be accepted, and don't think about the part which is outside the window. And yeah, here you can see that the line intersection parameters are set to are initially, to be set as t1 equals to 0 and t2 equals to 1. Coming to the implementation part. Okay, so first of all we will take the coordinates of the endpoints of the line, and I have already defined the boundaries of the window as 100, 100 and 250, 250. These will be 100, 100 represents uh, the top left corner, and other point represents the bottom right corner. So that's how the UI of the WinBGI is defined. So accordingly I have defined the coordinates for the boundaries of using these coordinates in the rectangle function. I will be making a window which should be used for the clipping purposes. Now I've just defined some variables as dx and dy to replace them with x2 minus x1. Like we have this x2 minus x1 expressions here. So if we replace them by dx, it just becomes a little simpler to write the code. Otherwise, you can just simply use the same expressions of x2 minus x1 and other p values. But just to make things simple, I've just defined dx and dy as x2 minus x1 and y2 minus y1. And p0 we are using for the left boundary, one for the, like we are using p0 for the left boundary, p1 for the right boundary, and p2 and p3 for the bottom and top boundaries correspondingly. So we are just defining those values which we were discussing earlier, and similarly we are giving q values for all the edges. The 0 represents left boundary, 1 represents right, 2 represents top, and 3 represents the bottom boundary. I think I made a mistake there. 2 represents the bottom boundary, and 3 represents the top boundary. And so we are just using an array to store these values. So the PQ values are stored in this array for different edges. Now after the values are stored, we will start judging about the line. So first of all, if any p values is found to be 0, we are iterating from 0 to 3. If any p values are found to be 0, then that line is supposed to be parallel to any edge, as we have discussed earlier. So how we will be dealing with that case? We will have to set the boundaries for the intersection point which can be intersecting, and we have to accordingly, after the setting the coordinates, we have to draw the line. So if the I value is less than 2, so these are the cases we are talking about, 0 and 1, which represents the left and right boundary. For the two edges, we have to actually alter the y values. If the y1 coordinate is less than y minimum, which is y minimum actually represents this edge. So if it is less than this edge, in WinBGI actually we start the origin is at the left top corner. So in that sense, the y minimum will come on top, but in other Cartesian algebra we will take this as the y minimum because this is the least value of y we are getting. So for the window, this is the least value of y we are getting. So for the I values 0 and 1, which represents left and right boundaries, we have to set the y1 and y2 values accordingly to check for the intersection. Remember, this is the case we are taking when one of the edges is coming parallel to our given line. Then we take another if condition where we judge for I greater than 1, which represents the values 2, 3 and 4. So for the right boundary, top boundary and bottom boundary, we have to set the x coordinates. So here you can see that for the right boundary we are setting y values and x values both. So accordingly we will check whether the y value and x values are less than the boundaries or greater than the boundaries and set them for the intersection. So after we have altered the values, and when we draw the line, only the accepted part of the line will be seen in the graph. Now this was the case we were discussing when some p value was found to be 0. I mean, for some edge the p value was found to be 0. Otherwise, when the p value is not found to be 0, we initialize the t1 and t2 variables, which represents the entering point and exiting point of a line according to a edge as 0 and 1. Now we will start calculating the q by p ratio for all the edges, and if the q by p ratio, according to the q by p ratio, this represents that when the line is not going parallel to any edge and it's just going in some other direction, it will intersect the different edges of the window, or in that case we have to set the t values so that our the line which we end up with is the line within the window. Only the portion within the window we have to draw. So accordingly we have to set the t values, because these t values actually represent the endpoints of the given line. So how will we do that? We will calculate the q by p ratio for all the edges, and now we will check if the p value for any edge is less than 0. We have already defined what this actually means. If the p value is less than 0, then the line is said to go from outside to inside. So this will represent the starting point of the line, and in that case we will actually check whether the t1 value we already have is less than the q by p ratio we have got for the edge. If for that edge the q by p ratio is greater than the t1 value, then we will set the t1 as the q by p ratio, which is represented by this temp variable we have defined above. Otherwise, if for some other edge or for any edge we find the p value to not to be less than 0, we find the p value to be greater than 0, it's the case when the line is going from inside to outside, and this time that very intersection will represent the endpoint of the portion of the line within the window. This time we have to check whether the q by p ratio is less than the t2 value which is initialized as 1. So if our q by p ratio comes out to be less than the t2 value, then we will set the t2 value as the q by p ratio for that edge. Now we have considered both the cases where line was coming parallel or line was not coming parallel to any of the edges. Now how will we draw the line which is not parallel to the any edge, and we have to just draw a portion of the line which is to be accepted. If the t1 value is found to be less than t2, this is the case. This has to be the ideal case, because t1 has to be less than t2, as t1 is the starting point of the line. So this will, if the condition is met, it will execute this part of this block of code. This is actually used to define the intersection point of the line with the window. So now we will have some new x and y, x1 y1 and x2 y2 coordinates. I've defined them in variables xx1 xx2 yy1 and yy2. So for the x1 coordinate, for the starting point we have to add the t1 value, the value corresponding to t1, as we have defined above. The t into p product actually represents t into x2 minus x1 product. So working on the same idea, we will be able to get the change in the x coordinate by adding the product of t1 to the p value of that edge. So similarly we have to find different other values. For x2 value represents the x coordinate of the endpoint, so we have to multiply t2 with the p value of that edge. P value of 1 actually represents the p value of the right edge, so it will actually help us out to find the new coordinates of the portion of the line within the windows. Similarly we have to do for y. This time we have to multiply t1 and t2 with p of 3, which actually represents the bottom edge of the window. Accordingly we will get our new x1 y1 and y1 y2 values, which we can use to draw the line using the line function. So I think that's pretty much all. I will just show you the output which I was getting. So according to the boundaries I defined, this was the rectangular window I was getting, and you can see that the line is getting accepted from 120, 120 to 249, 249. I entered the coordinates as 120, 120 and 300, 300. So the starting point is within the window, but the end point is outside the window. So it will just take the starting point and intersection point of the window and draw the line within the window. So I guess that's pretty much all. Thank you everyone for watching the video.